today we will be talking about another, I would say, interesting topic in the deep learning field, which is about RCNN. I think in the last session we have talked about CNN and everybody is comfortable with that concept. What is CNN? Anybody knows the full form of that? What is the full form of CNN? Can I get some response from everyone? CNN means convolutional neural network. That's true. Convolutional neural network, right? Now, this R is the additional word over here, which is about a region proposal. And we will try to discuss what does that mean, what we are doing in actually RCNN based architectures, and how it is different from normal convolutional neural networks. Obviously, in this architecture also, we will be using CNNs and the knowledge that we have gained in our earlier discussions. But some additional things we will do on top of that. That is something which we have to understand. What are the additional things we're supposed to do in this RCNN based architecture? To understand this in a lot more detailed manner, um, let's try to first of all understand few key terms which I really want to talk about. So till so far, everybody knows that what is the meaning of image classification, because that is what we have covered up earlier. Everybody knows that. So if let's say I will give you the image which is of human, so your model should be able to classify that, okay, this is human. If the image will belong to car, model will be able to classify it as a car. If the image is of, let's say, dog, our model will be able to classify it as a dog. Let's say we have a three categories: human, car, and dog. A mix of, these images only. So either my model will classify it as a human, any test image, or car or dog, considering we have only three classes. So that is the simple, I would say, meaning of image classification that we have learned till so far. But on top of this classification layer, we have two more concepts. So one is something that we usually learn about localization. Localization. In deep learning. And then we will talk about detection. Okay. So let's go to the images. So here, this is the main difference between classification versus localization. For example, if you will see this image very carefully, can you see the difference? What is the difference over here in this image? So let's try to first of all save this and then we can discuss further. Classification versus localization. If I will try to upload this image and just showcase you, see this? What is the main difference you are observing over here? So Khushbu is saying it's about object identification. Somehow, yes. Here you can see the simpler task that we have covered up in our last class can be easily done by a normal convolutional neural network. And by the way, we have different flavors or different models based out of this CNN. For example, I'm not really sure how many of you have heard about LXNet, VGGNet, ResNet. All of these are the different flavors, varieties of convolutional based neural network. If you really want to know more about this in a lot more detail, you can always refer my deep learning playlist. It's available on my channel. You can search with the name Priya Bhatia. And inside that, we have a deep learning playlist. Here you can see, I was just checking for you guys only, episode number 10, 11, and 12. This is basically a talk about these architectures only, which I have written over here, if you are not aware of. And yes, so Avinash is saying in the recorded videos, it has been taught. So that is again a good thing. If you have already learned from the recorded videos which I shared with you, so that's super. So basically the main idea is if you are aware about the different flavors of CNN, you will get, I would say, maximum accuracy when you are dealing with the classification task. In our live discussions, we have talked about just simpler version of CNN. Now, these are the advanced versions that we will be having. But there, again, major task is to classify it. Now, if you want that, on top of this specific image, if there will be some box which actually helps us to localize, to locate. Localize means what? Locate, right? The image using this bounding box, that is again something by which we will be able to understand that, okay, this is exactly where the cat is available. Because if let's say it's a big image having bigger dimensions, inside that maybe only cat is there, but outside the cat there will be a background image as well. So if let's say I just want to localize, I just want to highlight where my actual cat is there in the whole image, that is only done with the help of this RCNN based task. So this is something which you can see on the outer part. This box is what we called as a bounding box. What we call this? A bounding box. So our main purpose in RCNN is to detect the image where actually exactly it is available. Now, one term is what we have understood, image classification task. Then we have understood that first of all, we will do a classification. And then we have to learn how can we locate this exact image. So the other concept is what we have talked about is localization. But still you will find there is some other term in the world of computer vision, in the world of deep learning, which we called as object detection. Now, many people are confused between these two words as this localization and detection. These two words in the industries are quite used interchangeably. So what is the main difference? When we talk about classification plus localization, here our main focus is that whatever class I am concerned with, for example, I am concerned with the cat class, so it will just do the localization of that cat only. So on a single object, it will just try to create a bounding box. And that's what you can see on the image as well. I hope you can clearly observe. So it won't detect any other thing, even though let's say apart from this cat, car is available, or maybe some other objects are also available. It will just detect that class which we are focusing on, which is cat over here. But when we talk about object detection, now let me showcase you some interesting image for object detection. Can you see? This is the best example of object detection. So here what you are observing, or maybe this is also a good example. So if I will just try to save this image and showcase to you, it's not a PNG. So just give me a second. If I will just try to fetch this, maybe single image is also enough to understand the concept which I'm trying to convey. This is the literal meaning of what we call as detection. Detection meaning that now whatever you can see over here, for example, you will provide one image to the model. Now model can automatically see multiple objects in that image, and it will automatically tries to give us the answer that, okay, this is horse, This is, let's say, dog. The below part, you can see person is there. Here also it is a person with its corresponding score. That person 99.2%, horse 99.3%, dog 96.7%, person 97.9%, and so on. So do you get an idea now? What is the difference between a simple classification task, classification plus localization task, classification plus object detection task? Is this clear to everyone? These three terms are clear. So basically, three things are there. One is simple classification. Then we have talked about what is the meaning of localization. And then we have talked about what is the meaning of object detection. I hope these three interesting problems in the field of deep learning is clear to everyone. Percentage is kind of a probability whichever model is giving for that specific class. So it belongs to person, what is the kind of a probability it has? It belongs to horse, what is the probability? So whatever be the maximum probability, that will be the result whichever model is giving to us. So here, obviously, when we're talking about object detection, it is trying to focus on multiple objects which are available in a single image, which are available in a single image. In localization, it is just focusing on a single class detection. By the way, in localization also and in the detection also, bounding box will be created. I hope you can see. Here also we have a box available and here also we have a box available. So in both of these cases, the common thing will be a bounding box. In classification, it's a simple classification task which helps my image to classify that which specific class it belongs to. I hope it is clear to everyone. All good with these terms? Can I get a quick confirmation from everyone so that we can move ahead and try to understand the intuition behind now how these things will work internally? So today our focus will be on this localization concept and this object detection concept because we already have covered up this classification concept in our previous classes. CNN normal model will help us to do the classification, but if we want to do this specific task where we have to focus on the object and then classify it as per the individual classes, their normal CNN models will automatically get failed. And that is where we have this interesting model called as RCNN, region proposal. What is the meaning of that? It is basically in the given image trying to find out the specific regions, right? We are focusing on the regions of interest. And that is where we will be focusing on this RCNN based model. Apart from these three core tasks that we have in deep learning, we do have one more concept called as segmentation. Let me cover up that as well before we will proceed ahead. What is the meaning of segmentation? Have you heard about this term before this session? What we are doing in a segmentation, I think I might have discussed this term in our previous sessions, not really sure. Segmentation is also another task where our main focus is to detect the boundary lines of any region. For example, let's say your task is to detect the cancer cells in the patients, or your task is to detect the lung in the CT scans, lungs portion in the CT scans, right? So basically, in all of these tasks, you will go ahead and work around the segmentation problem. So if I will give you one simple example for this problem was my research problem at IIT Hyderabad. So let me just open my research paper, fatafat, and then I can showcase you an interesting example for this, and then maybe we can move ahead. So can you see this research paper? This is the research paper which I published at that time. This is basically about COVID-19 data, and we were focusing at that point of time with one specific problem which usually happened to the patients who were suffering from COVID-19. So I hope you can see that this is an image of what? Can you give me the answer? I hope everybody knows what does this image belongs to. This is the image of. Can you guys guess? It's a CT scan based image. And yes, inside this black area is a lung area. And inside that, you can see that there is some white area available. Can you see everyone? This white area available, which they're calling it as either ground glass or consolidation. I hope everybody can read this. So what was observed by the doctors that the patients who were suffering from COVID-19, they will be having their lung infected, firstly. And if the infection is less, they will be having a very small, this white sort of area inside the lung. If the infection is more, this white area is quite big. Okay. So that is where they have either focused on a problem of ground glass or consolidation. If any patient inside their lung have major white portion, means they have a consolidation, it means that that specific patient is very serious. Means that person have to instantly relocate to ICU and done the operation. We have to do the operation, means doctor's recommendation is this. So that was the whole point, that at any point of time, given the patient CT scan, the lung factor we have to first of all find out, and then inside that, wherever this you can see white region is there, that is the issue which our model wants to detect. Obviously, if doctors will detect, it will take too much time, and at that point of time, if you remember, the quantity of these COVID patients was huge, at least more than the number of doctors that we had in India, right? So that is where, by the way, these CT scans and all those things will be taken care of by the radiologist. So radiologists are quite few at that point of time. Still also, it's not that we have a huge quantity of radiologists available in India. So that is where these not ML, these DL based models comes into picture. And that is where the task of image segmentation comes into picture. So this is a inflamed area, infectious area. And now we have interesting models available in the domain of deep learning, in the image segmentation task, where the first approach is that, we will be having this input image. So let me just copy one of the image, and then maybe we can discuss what is the meaning of segmentation further. Let's pick up the last part, and maybe I just pick up only this one, and let me paste. I hope it is visible. So what is happening over here? We will be having a actual CT scan of the patient. What we will do? We will find the region of interest. Obviously, I don't need all these outer portions available, even this black area available. We don't require it, right? So what we usually do, or what our model we will try to do, that we will try to focus on finding the region of interest. This is what we call as region of interest, where I want to do that segmentation task. So I have figured it out that it is basically inside the lung. So I will just try to capture that lung area. And once I capture that, now I can just filter out the infectious portion. And this is what we call as a segmentation. This is a task of image segmentation. Can you see this yellow portion? This one, this one. This is the portion which is detected by our model, not by doctors. It's by our model, which we have trained on the actual patient's data. So here you can see that, our model will be easily able to identify that where is the inflamed region is inside the patient's lung. And then we can simply apply a bit of maths to find out the volume of this inflamed region, the volume of this inflamed or infectious region. in the lung. And if the volume is quite huge, it means that patient is serious because the infection is very huge. If the volume of this inflamed region is less, it means that the infection is also very less. I hope you're getting my point, what I'm trying to convey over here. All good? Can we move ahead? Similarly, you can take several examples of the same. Let me just showcase you few more examples for this image segmentation task. It's very widely used technique in the field of healthcare. When we have a image-based data, let me just showcase you few images for the same. So can you just see this part? Lung tumor image segmentation. You can maybe after this session go ahead and explore few research papers as well. But I hope that you got my point that what is the meaning of segmentation. Is this clear to everyone? Is this clear? What is the meaning of segmentation? So here also you can see. Can you see this region which they are trying to find out? This one. This might be a tumor cell which they are trying to find out from the entire CT scan. I hope it is clear. So now we are done with the few terms in the field of deep learning, the problems that our deep learning based models are dealing with: classification, localization, object detection, and segmentation. All good? Shall we now move ahead further? All good, right? चलें आगे? Now we will see that how this RCNN based network works and exactly where we have to use this. What is the meaning of region proposals over here? Okay? And for that, let me try to take the image of car. Yep, this is good. So this is the entire pipeline with which it is basically used to detect that uh, car and its bounding box. That is the main thing today we have to understand, that how it will be able to, for example, if I will just provide this input image, I hope you can see on this left extreme, this is the input image. Now in this input image, if I'm just looking for a car, you can see in this entire image, we have an image of this road as well. This road, this greenery is also there. But what I'm majorly focused on is this car or maybe this car. So what I want is that our model will be able to locate basically the car based things available in this picture. I hope the problem statement is clear to everyone. Is this clear? Is this clear what we are trying to do over here? Shall we move ahead? Shall we move ahead? Now, what was the traditional approach to solve this problem? What was the traditional approach before this RCNN comes into picture? In the traditional approach, we just have the CNN, right? We just had the CNN, normal CNN. And you all know that with the CNN, we can easily do the image classification task. But we just had only a single image. This is the image that we will be having. So let me do one thing. Let me do one thing. Let's say this is the single image we had, right? So in the traditional CNN-based approach, what was the initial mindset of the researchers? Researchers thought that, okay, we don't have a bunch of images, so how can we do the classification task? Let's say we will be having a classes that whether in this image car is there, or let's say truck is there, or let's say dog is there, or let's say any other class. For example, here you can say aeroplane, TV monitor, and so on. So we do solve, basically we are solving a multi-class classification problem only over here as well, right? Multi-class classification problem only. But initially what they thought is that we will try to create a similar size pictures. We will try to start with a rectangular portion. Maybe it is having some height and the width. And what we will do is we will try to drift one by one, and we'll try to take a sample of all of these images. I hope you're getting my point, like this. So in one frame, we will be having multiple images. By the way, these size will also be same, although I cannot create it over here. But I hope you're getting my point. They're just somehow picking up the samples of this specific image, and they're trying to create something called as a rectangular boxes of each having the same size. So what will happen is that obviously there will be some portions, for example, in this portion, 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 automatically the car image will be captured, and wherever the probability of this car image will be high, so my model will be easily able to classify it and say that, okay, this is where the car is available. This approach will work or not? Is this approach will work or not? Are you getting my point? What they have done initially? So they have tried to uh, capture the subsamples from this main input image. For example, there can be multiple images we can create from this one single image, right? And then we can locate that where exactly the car is available. So we will obviously reach to one subsample of an image where definitely the car will be available, or two or three images will be there where the probability of the car will be high. So in that sense, maybe we can create two classes. Uh, One belongs to car, another one belongs to, let's say, road, maybe something like that. And somehow you are trying to design a simple CNN based model, which will try to give you a probability. You are applying, let's say, a softmax function. And in every image, either the probability of car will be high or the probability of road will be high. So wherever in whatsoever image you will observe that the probability of car is high, it means that in that specific image, this is the area, this is the location where the car is available. Quite easy, quite understandable. And I think this also works well. But what is the issue with this specific approach? What is the issue with this specific approach? Let's say the input image size, width, and the height is, let's say, capital W and capital H. And let's suppose the smaller portion, the rectangular part which you are trying to create is, let's say, small w and small h. Now, if I'll ask you for a given image, for a given input image, how many possible number of possible number of sub images can be formed here? What will be your answer? For a given input image, how many possible number of sub images can be formed here? What will be your answer? Any guesses? For example, I will give you one simple question. Let's try to relate with that. For example, I have an input image, and here the capital W is, let's say, 224. This is the size. And capital H is also, let's say, 224. So W is also 224. capital H is also 224. Now, if I'll ask from you that, if we are trying to create this small w and small h with respect to each and every corresponding smaller images, how many number of possibilities are there to create the images over here? Any answer? First of all, evaluate width wise how many possibilities are there. Then evaluate height wise how many possibilities are there. I hope everybody knows the mathematical formula to evaluate the range. It is capital W minus small w plus 1. This is how we evaluate the range. For example, if I will say that I have a number from 1 to 10, how many number of possible values are there inside that? So what you will do, you will say 10 minus 1 plus 1, means total 10 values are there. Similarly, in the width part, capital W is the highest width which we can take, highest width which we can take. Maybe we can take the entire image in one go like this, or the smaller we can take is W, which is, let's say, equal to 1. So here we can assume that this W will be starting from 1 and can go to capital W. Do you guys agree with me? Similarly, we will be having a range of H. We can start with 1. We can take a height as a smaller unit as 1, and it can go to capital H. So the range of this height is also capital H minus small h plus 1. Do you guys agree with me? And if you multiply this, this could be the dimensions of the input images. So I hope you can imagine over here, if I will be talking about, let's say, 224 and 224, and considering that small w and small h is starting from 1 and 1, so it will be 224 minus 1 plus 1 into 224 minus 1 plus 1. So basically, if you multiply these two for a single unit as 1, you can imagine that we will be able to get some bigger value over here. What is the value, by the way? Can you do the maths? It is, someone said, 50176. And this is when the value of w and the value of h, small h, is equal to 1. When it will become 2, 3, 4, till it can go till 224, you can imagine the maximum value will lie as 224 minus 224 plus 1 into 224 minus 224 plus 1. So you can again recheck this. The range will lie starting from 1 till this 224. So basically the point is that there are multiple permutations and combinations that we can apply, and there can be many possibilities in terms of getting this region. Do you guys agree with me? So for every specific region portion, for every specific image, getting this classification task again and again is quite complex task and is quite computationally expensive task. Do you guys agree with me? Is quite computationally expensive task. Do you guys agree with me? So if we will try to apply all the permutations and combinations, starting from W and H unit as 1 till 224, so can we say that this is a very huge number which we will be able to get at the end of the day? Right, everyone? So that is the consideration which researchers have also realized. And because of that, they come to this RCNN. So do you get the problem clearly before now we will jump towards what this RCNN has does? Yep. Can I get a quick confirmation over here? Is this clear? चले आगे. Do you get my point? Why traditional approach is a big failure? Why it is a big failure? Is this clear to everyone? If you have any doubts, please go ahead and ask. Otherwise, give me the confirmation. I will move ahead. All good? What about others? All good? Can I get a quick confirmation from everyone? Now, this is where you will start appreciating the concept of RCNN. RCNN says that, if let's say in total, by doing all the permutations and combinations, let's assume I'm giving you some random number, there might be 600 million boxes that you are creating individually by doing, let's say, all the permutations and combinations and then adding them. Why not to focus only on those specific regions which are of interest? For example, few minutes back, I have given you one research paper of mine as an example that if let's say there are multiple possibilities, but we know that this actual regions are not of interest, right? They're not of interest for us. If let's say we want to detect the ground glass or consolidation inside the lung, what we are focusing on only on this lung portion, right? Only on this lung portion. So why we will take care of all other possibilities? So the next concept comes is how to figure out this region of interest, how to find only those specific boxes which actually contain some interesting car values or the region values. And that is where I hope everybody knows that internally when the image will be stored, it will be stored in the form of, in the form of, can I get a confirmation? Internally, when the image will be stored in the form of a, how the images are stored inside the memory, inside our deep learning based system, we have discussed in our previous discussion, it will be stored in the form of a pixels format. So do you guys agree with me that when there will be an box of, I would say, let's say this road based box will be there. So they will be having a similar pixel values, whatever be the values are, I don't care, but they will be having a same pixel value. Basically, all of these will be having the similar pixel values. Do you guys agree with me? Whatever be the possible boxes we can have over here. Similarly, these green values, these green entries will have a similar pixel value. Here also these green entries will have a similar pixel value. Here also this road values are also same. But then there comes a point where they can observe a change in the pixel value. There will be a sharp change in the pixel value from, let's say, road pixel to a car pixel. Do you guys agree with me? So when internally the image will be designed. So basically we are doing a optimization over here. Instead of directly feeding all the possible images, which might go up to millions or trillions, we are first of all trying to extract the important region, which we are calling it as a region proposals. So basically, if in the input image, we can have let's say 60 million based input images, which can be possible, which can be done via these permutations and combinations. We are trying to figure out only, let's say, 2000 region proposals, which can be car based regions. Now, from this 2K regions, we can apply again CNN based architecture to further classify that whether the picture belongs to a car or not. But here somehow we have done the optimization, right? Instead of directly feeding the 60 million base input images, permutations, combinations directly to CNN, and then applying a, let's say, softmax layer, if it's a binary classification, sorry, multi-class classification, or applying a sigmoid layer if it's a binary classification layer. Before that, can't we do the optimization? So here this optimization is being done. So it is being observed that where there is a pixel change in terms of, let's say, the value of this road-based pixel to a car-based pixel. So wherever we find that, okay, there is an internal shift in the pixel values, we can simply filter those images. And we are calling it as a region proposals. So there can be 2000, let's say 3000, or maybe only 1000 images that we have filtered down in outside of the range where there might be the portion where the exact pixels of the cars will be available. Now it might be the case that somewhere this is also, this is also, this is also, this is also, and this complete also is a portion of car based region proposal. But outside that also, outside of this 2000, we just want only that specific image as a car where this proper bounding box will be there. Do you guys agree with me? Are you getting my point? So there might be the images where just this portion is coming up. Only this portion is coming up. Only this portion or this portion is coming up. There can be image where complete image is coming up. What we are looking for is a complete image. That is also another thing which we have to take care of. But before jumping to that point, that how that specific thing will be taken care of, is the meaning of this extracting this region proposals and how it is being done internally. What's the thought process? Is this clear to everyone? All good? How we are doing optimization over here, or how the researchers have done optimizations over here to extract only those regions which make sense in order to detect the cars. Is this clear? All good? Can I get a quick confirmation over here? I don't know whether there can be some image which I can showcase you. To detect images in objects. Yep, this can be considered as an example, which I actually want to share with you. This might give you an idea, but I hope you already got it, but still, just to understand for those people who are still unclear what I'm saying. For example, this is a representation of grayscale image. It's a very simple example so that you will get an understanding. Let's take until this point what actually I'm trying to convey over here with a shift in the pixels. So if let's say in this pixel values, I want to determine this specific region. So can I say that wherever this specific region is there or the specific color is there, everywhere the pixel value is same? 0.851, let's say in this data. So if I will ask from you that, hey, this specific part, pixel value is 0.851. Can you tell me how many times and where exactly this image, this specific, I would say color is appearing? Is it difficult for you to determine if considering you have a corresponding image data with you? So now you can consider that internally for car also there will be a pixel value, right? So wherever the car will be available, it will be having some sort of similar values available. So for my model, it won't be difficult to extract the same regions which I am interested in. So I am saying that I want to extract maybe this specific region and this specific region for my interest. So this is my region proposals for my task. So instead of just focusing on all the colors, I'm just focusing on only those pixels which are of my interest or where there is a major shift from one pixel to another pixel. I hope you're getting a sense of what I'm trying to convey over here. Similar sort of thing is happening over here. It's not a grayscale, it's a RGB based image. So we will be having three signals over there, and in every signal, we will try to check the shift. But somehow we will be able to, or our model will be able to extract only those regions which are very helpful, which are very useful, and which contains those pixel values of cars. Is it clear? All good. I hope it is fine. Perfect. Now, if it is clear, if it is clear, so what we have understood till so far in the pipeline, we have understood that if, let's say, we will be having a input image, whatever be the input images, the first task, the important thing, one more important thing is that all the images which will be part of RCNN, they will consider by default as a square shaped image. So if, let's say, the shape of the image is not squared, you will have to make sure that you will make them squared. Okay. So anyhow, if, let's say, we will be having an input image, it will try to extract, first of all, as per the detection part, the region proposals of the same. Region proposals of the same. Wherever the possibilities are there. So if, let's say, it is 2K, it has determined. Now for every specific image, for every single image, 2000 times, it will repeat the same task. What is that task? Now you have to listen. So it will make sure that every image will be of square shaped. That's what I have talked about. So if the shape of the image, which it is trying to detect as a region proposal, is not square, it will try to convert that. So this will come under the pre-processing task. Once this is done, the next task is to now pass that image inside this CNN base layer, which you can see. So here, whatever conversations we had in our previous discussions, the convolutional layer will be there. The max pooling will be there, right? Depending upon what sort of architectures it is using. It might be using LXNet, it might be using VGGNet, any architecture, which is basically used to detect the what it will give to us as the features, right? So you can see it will compute the CNN features. So we will apply the CNN based layer over here to compute the feature vectors. And I hope everybody knows how it will be able to compute the feature vectors. So there will be a filters available. For every filter, it will try to go inside the input image, apply that multiplication process, give us the feature vectors. Now, whatever be the final values we will be getting, what will happen next? There will be a flattening layer. I hope everybody knows what is the meaning of a flattening layer. So your data will be in the form of a 2D image. It will convert that into a one-dimensional image. Have we covered up all these things in our last class? Do you guys remember that? For example, if, let's say, your final feature vector, which you're getting as an output matrix, is maybe 32 cross 32 cross 4, let's assume, or maybe cross 3, whatever be the cases. So in that case, you just multiply these numbers, whatever be the output you're getting. So what is the answer of this? 32 into 32 into 3, 3072, right? So that many input neurons you will be able to get, comma 1. Do you guys agree with me? That many input neurons you will get. Now you will apply this into a neural network. So here you will be having a fully connected layer. It might be a dense layer as well. You can create a hidden layer of this. Now, this hidden layer can be one or two, whatever be the perfect optimization you can get for that. Finally, you will be having a, I would say, output layer. If let's say you are dealing with 10 classes, let's assume. So in that case, you will apply a softmax function, which will give the probability to each and every class. So for example, you will be having car as one class, human as another class, dog as another class, truck as another class, cat as another class. Uh, what else? Horse as another class. What else? Any other example? Maybe mountains as another class. Whatever be the objects you can think of, beaches as another class, cycle as another class. So how many classes we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe scooty as another class. So let's say you are dealing with a car. So the probability of this car should be very high, maybe 0.90. Remaining probabilities are, let's say, this 0.01 only. And this is how your model will be able to classify that, okay, this is where this specific image which I am getting in the region extraction part belongs to car. तो ये तो हो गया हमारा काम to classify that image as a car. Classification is done. But there is one more important thing which we have to taken care of in this specific part. There are two things which will happen after this flattening layer. One is this fully connected layer, which helps the model to do the classification task. The second thing which will happen after this flattening layer is, any guesses? Any guesses for this? Anyone? The second thing which we have to do in RCNN, apart from doing an image classification task, is, okay, it will be able to classify it as a car. So you can see CNN layer is there and it is saying that, okay, car is yes, or providing a maximum probability, or in the same thing. Now, apart from this, there is second thing which we're supposed to do over here. What should be that? Any guesses? Anyone? Not segmentation. This is not segmentation. It is just creating a bounding box to that image. Yes, everyone? वो भी तो create करना है ना हमें. अगर हमारे पास कार आ रही है तो आप देख रहे होगे in the output what we are expecting is this yellow colored box. So after this specific part of flattening layer, we will try to create a bounding box as the second important step which we're supposed to do over here. तो यहाँ पे तो आप लगाओगे classification वाला loss function. So here, if you remember in the last class, do you remember what is the loss function we have used over here to do this task? It was cross entropy. If you don't remember, you can go ahead, check the last session file, you will be able to get that. Bounding box is something which is a regression based problem. And I hope everybody knows what is the difference between a classification versus regression problem. So what we will do over here? We will be having a correct dimensions, target dimensions, which is, let's say, X, Y, W, and H for a given image when we will train our model. And whatsoever image your model is classifying as a car, it is having its own dimension, which is X dash, Y dash, W dash, and H dash. And you will make sure at the end of the day Maybe you can apply over here the loss function as mean squared error. So you will have to make sure that these two values should be approximately equal to each other. Why this is important? Because as I have mentioned that for this image, the region proposal can have for this single car image, let's assume, I will just try to grab this image if I can. Where is the research paper of this? I think I had opened the research paper of RCNN as well. Mm, so the simple idea which I want to convey over here is, let me extract from here itself. This is the image, right? This is the car image. Now, when our model is extracting multiple region proposals, it might extract this specific region also as car. This might extract this possible region are also as car. This is also a part of a 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 car. Because wherever the few pixels of cars are also there, that is a part or a portion of a car. But what I am looking for, that my model will classify this specific region as a whole car. So if you have an object available over here, what we want is that bounding box is as close as this, which will cover it completely. It should not be halfway. For example, if let's say I have an object available over here, my bounding box should not cut this. It should not be something like this. This is wrong. It should not be something like this, taking extra space of black. This is wrong. This should not be something like halfway also. This is wrong. What we are looking for is it will take the complete image and the box is as close as the image. So we will be having this target dimensions available with us when we are training our model. And here we are saying that, if you will be having in the region proposals any other dimension, look for some better bounding box. Look for some better bounding box. So it will train our model in such a way that it will reach to a point where it will be able to extract this ultimate, I would say, boxes, which actually we want. So basically in RCNN, our task is not solely linked with the classification part. So it's kind of a classification plus regression that we are doing. Classification to classify that what specific class it belongs to. Regression to create that bounding box. So finally, what we will do is we will try to add these two loss functions together. So for the very first time, we are seeing over here that the classification based loss function and the regression based loss function works together to give us the final result. I hope it is clear to everyone. This is the intuition behind RCNN. If you have any doubt, please go ahead and ask before we will proceed ahead. In the meantime, let me check what happened. Uh, no space left on device, and even I don't have a bigger RAM size. So I will look into it. Maybe I have to take one sample image to showcase. Let me check what we can do over here. But is the intuition is clear? Tell me if it is clear to everyone. See, when we use regression based problems, we use regression based problems. We use regression based problems when we want to predict something called as a continuous data. I hope everybody agrees with me, right? Now, what I'm saying is that for our regression, uh, region proposals images, we will find multiple images where car is there. And for every image, we will be having the dimension of XY, where actually that image will be located, X axis and Y axis, and their height and width. So you will get H dash and W dash as well, right? So, or vice versa, W dash and H dash, which I have written above. So you will get all of these four, I would say, values available over here. In fact, in the output image, it should be 4. So we will be having for every feature vector, these 4 values. 4 points will be there. And it will be nothing but I think 4096 should be there. So we in our dimension, we will get 4 values over here. Why 4 values? Because for every image, we will be having this X and Y axis and this width and the height. What we are saying over here that there will be a target box dimensions which is available to us, which we are looking for. Maybe you are saying that I am looking for this specific dimensional input image, which basically my model will be able to target it as a car, as a dog, or something like that. And that is something which we are saying it as X, Y, W, and H. So now in every iteration, it will try to compare that whether this dimension and this dimension, are they same or not? If they are not same, it will reiterate and check for bigger dimensions. For example, यहाँ पे आपके dimensions छोटे आ रहे हैं, right? यहाँ पे आपके dimension छोटे आ रहे हैं, तो मेरा मॉडल कहेगा कि नहीं नहीं, मुझे तो बड़े dimensions पे काम करना है, थोड़ा सा और बड़ा करो, थोड़ा सा हाइट को बड़ा करो, और बड़ा करो, और बड़ा करो. सो इट विल फाइनली रीच टू अ पॉइंट जहां पे येलो कलर वाली जो चीज है वो हमें डिस्प्ले होगी, जिसमें पूरी की पूरी कार जो है वो हमें एक ही बार में डिस्प्ले हो रही होगी, क्योंकि हमें कार की इंटरनल्स नहीं चाहिए, हमें फुल फ्लेज्ड एक ही बाउंडिंग बॉक्स चाहिए जो कि कार को रिप्रेजेंट कर रहा हो. एंड दैट इज द मेन रीजन, क्योंकि हर बार अब यहाँ पे क्या हो रहा है, रीआइट्रेशन होगा, लर्निंग होगी, तो यहाँ पे लॉस फंक्शन क्या रखेंगे हम, क्योंकि यहाँ पे हमारे पास जो वैल्यूज है वो कॉन्टिन्यूस फॉर्म में है, राइट? कोई क्लास तो है नहीं है. दैट इज वाई वी विल बी यूजिंग दिस रिग्रेशन बेस्ड लॉस फंक्शन ओवर हियर, मे बी MSE, मीन स्क्वायर्ड एरर, बिकॉज वी वांट कि जो y और y डैश की वैल्यू है, या x और x डैश की वैल्यू है, या w और w डैश की वैल्यू है, h या h डैश की वैल्यू है, वो मिनिमम होनी चाहिए, उन दोनों का डिफरेंस जो है वो मिनिमम होना चाहिए. आई होप इट इज क्लियर नाउ. ऑल गुड. ठीक है. नाउ आई एम शेयरिंग योर लिंक ऑफ दिस पेपर. In the meantime, I'm just seeing how can we do the implementation, that too in a live discussion itself, because usually this is something where we should have multiple images and a good configured I would say GPUs, or maybe higher configured laptop. I do have, either I will do in my local, but I'm planning to do in the collab itself. So maybe let me try to take simpler data. I have to see. But in the meantime, you can go ahead with this research paper and check this out, what is being mentioned, whatever things we have covered up till so far. Is this something which is relatable to what it is mentioned over here? There is one more interesting article which I was reviewing before this session. You can check this as well. Firstly, you should check this article and then research paper, क्योंकि article को समझना थोड़ा सा आसान होता है. So you can check over here कि यहाँ पे इन्होंने कैसे काम किया है. बेसिकली इन्होंने इमेजेस जो हैं वो रिसर्च पेपर से ही निकाली हैं. So you can go ahead and read all these things. Uh, in the meantime, I will just look on to this implementation part. चले आगे. So let me showcase you. So I was thinking of giving you some complex example, but the point is, as I have showcased you, first of all, it is taking too much time to train. Although I have uploaded this for training almost half an hour back from this session, but still doesn't work because it might require a huge RAM size, which can be done if I will take a pro subscription of this, but I don't think it is required because we are doing here for just understanding purpose. But definitely when you will be working in a real time data, you will be dealing with a huge uh, amount of images in your data set. For now, I have just taken a single image, which I have captured from this Kaggle uh, sample data of object detection. So let me just first of all showcase you this image. Uh, just give me a second. By the way, I will upload everything in today's drive link, so no need to worry. But let me just showcase you. I have taken this image from Kaggle just to give you guys one example. So this is the image. I hope everybody can see this image, right? Now, we want this image to share and just check that how this RCNN will be able to detect the object inside this. That's the main target. Okay? I hope it is clear to everyone what we have to do. So what we have done, now I hope you remember the intuition behind that. So what we are doing over here, we are defining the fixed region proposals. Do you remember I told you that we will define our x-axis, y-axis, width and the height? So this is simply a function which is returning a list of predefined regions in the image, which basically I am expecting in my object. So this actually simulates the region proposal step of RCNN, right? Now, what I have done, I have built the classifier to extract the features from my input image. Here you can see I am mentioning the number of classes as 2. Basically what I am saying is just try to determine 2 classes only, class 0 and class 1, where you will detect the object and define it as 1 class or 0 class. Okay? Now there will be an input layer 2D. So basically this is something which you can see till so far. This is basically used to design the classifier. Now, we are nowadays using a pre-trained CNN-based models to do that step. As I have mentioned, in CNN, we do have already pre-trained models like LXNet, VGNet, ResNet, MobileNet V2. So all of these are the, I would say, um, inbuilt pre-trained models we have. Directly we can use them and this will help us to do our task. So rather than creating any CNN model from scratch, although we know how can we create it, I think you guys remember in the last session we have discussed how can we create a CNN based model from scratch. Here we are using this MobileNet V2. It's a pre-trained model, you can say, which is based on the CNN architecture only. You can just go ahead and explore about these architectures either from the recordings which have been shared to you or maybe from my YouTube videos, whatever you feel is comfortable to you. Now here we are trying to build a classifier which will take the input shape. We are applying a pooling over there. At the end, we are applying an output where we are defining the activation function as softmax so that it will be able to give me the probability of a class. Now, this classifier inside this, we are calling our model build classifier. So it will just build the classifier on top of it. Now our classifier is ready. We have to just provide the image, and what we are doing over here, whatever image is there, we are trying to convert them into RGB and trying to plot it. So that in the output, the input image is visible to me. So you can see now, if you will just try to check this out, this is the input image which we are working with because we have tried to print this. Now what will happen? We will try to get the regions. Once we get the regions, if you remember, I told you the first task is if the captured regions are not of squared shape, So in RCNN, we make sure that images should be of square shape. So we have tried to convert them into 128 cross 128 by cropping them. And then this is something where we are trying to do the data pre-processing in order to make sure that our input image that we are passing in the regions part should be basically aligned with the model that we are using as a classifier. So this is our simple pre-processing technique where we are trying to convert our crop image into an array, pre-processing that, and then expanding the dimensions so that the issue of the reshaping part won't come into picture. After that, we will try to extract the features by using this base model. Base model is something which we have defined as MobileNet V2, which is a pre-trained model. So what will happen is, once you will apply this CNN-based model, it will try to extract the features. And once your features are being extracted, you can pass those features in the classifier and it will give you the predictions. Once you get the predictions, this is what we have covered up in our last class as well. Now, in our model, let's say if we will be having two classes, so it will try to check that what is the probability of a highest class. So basically here, what our model is doing, whatever be the probability of a higher class we will be having, it is classifying it as a, if the prediction class is equals to 1, we are defining the color as red, otherwise the color will be green. So we are defining only two colors because we are working on only two classes for now. One is the class 0, one is the class 1. So here we are defining the color of that bounding box. We are saying that if the class is 1, so if I will showcase in the output as well, if the class is 1, it is red, class 0, green. So that is what we are mentioning over here. If the class is 1, make it for red. If the class is 0, make it for green. After that, we are defining the rectangle patches over there. And then you can see over here, we're defining the text by saying that class 0, class 1, whatever with prediction class we're getting over here. So when you will just try to show this image, you will be able to see that we are somehow getting in this entire image two classes. Class 0, which is represented by green color. So this 0 class is somehow getting that, I would say, rat based data. And this one class is basically getting the background sort of image of this greenery. But still here you can see that this class 0, here we will be having two class zeros available. And in another class 0, the rat wala part is very less. Can you observe over here? Still it is trying to detect this. What could be the possible reason for the same? Any guesses? Yes, Shreya, do you have any question? Please go ahead if you have. Yep, any guesses? Anyone? Any questions? What I'm trying to convey over here? Any guesses why it is detecting the, basically, if I will just open my Epic pen, you will be able to observe it is detecting this specific area. Why I'm not able to write over here? This specific area also as class 0, and this is also as class 0, and this is simply a class 1. This makes sense and this makes sense. Why this is a class 0? This is my question. Any guesses, anyone? Pixel changes there. That's true. That's true. So basically, if you can see, somehow this portion is covering up. Okay, my pen is not working fine. This portion is actually covering up. So let me just go back to the output image that we're getting. Let me remove this first of all. If here you can see, right? This is the class 0. Aha, what is happening? This is a class 0. And this specific area, if you will observe, this is common. Not really sure. Might be here also it is getting a similar sort of pixel. Might be. So that is the reason the model is covering up this as a whole. This is completely different class for sure because here neither this area is covered up nor there is anything in the background. It's just greenery is there. So this is a separate class altogether. So somehow our model is getting a similar sort of pixels over class 0 in this green region. That's why we're getting two class 0s and one class 1. This is a basic architecture of how CNNs will work. And that's the overall discussion that we had designed for today. Now I'm open to take any doubts and any questions if you have. Let me just first of all share with you this notebook as well. Again, I'm saying I have taken a very simple example, but definitely you can try to work around with a multiple set of images now. In fact, rather than just taking a single image, you can download few more images from Kaggle and then check that how this RCNN is working on those specific input images as well to detect the regions, bounding boxes, and the objects as well inside it. So this is the task for today. So let me write it over here. The task is uh, pick few more sample images from the Kaggle dataset and try to check how it works on RCNN based model to identify the objects. This is the task.